Welcome to GeoNews Radio, ready for another deep dive into some really cool new research that's changing how we see our planet. We've got ancient tectonic plates hiding where they shouldn't be, AI helping us find valuable stuff, and even a peek into the deep Earth processes that shape everything. It really is amazing how these discoveries make us rethink things we thought we knew about how the Earth works. Let's start with those ancient tectonic plates they found under the Western Pacific. It's weird because they're nowhere near any subduction zones. Those are the areas where we usually see tectonic plates sinking back into the Earth's mantle, right? Right. This unexpected location throws a wrench into our current plate tectonics models. It suggests that these plates could be leftovers from way back when, maybe from a time when Earth's tectonic processes differed totally from what we see today, like finding a fossil of Earth's ancient tectonic activity. But hold on, how did they even find these plates so deep down? They used this super high-tech method called full waveform inversion, which is a kind of like giving the Earth a super detailed MRI. They looked at the entire waveform of seismic waves, not just the first arrival, catching all these little details about the Earth's insides that we usually miss. That's how they found these old, dense plates hiding deep in the mantle. So, by looking at the complete picture of those seismic waves, they saw what was hidden before. It makes you wonder what else is down there just waiting to be found. It definitely shows how powerful technology can be for understanding our planet. And speaking of technology, let's talk about how AI is being used to finding those hard-to-find gold deposits. This one is really interesting. We all know gold is super valuable, but finding it can feel like searching for a needle in a haystack. How is AI changing that? Imagine analyzing tons of geological data, everything from maps and soil stuff to underground readings, and then being able to predict where the gold is with crazy accuracy. That's what mineral prospectivity mapping, or MPM, is all about. So it's like teaching a computer to think like a geologist, but on a much bigger scale. Exactly. These algorithms, often using things like random forests, find patterns and features in the data that tell us where gold might be. They can then point to potential gold hotspots that we might have missed using old school methods. That's wild. It sounds like a total game changer for mining. Are there any real-world examples of this actually working? Oh, for sure. There was a study in the Geraldton Greenstone Belt in Canada where they used MPM to go through a ton of geological data, maps, underground measurements, soil data, the whole works. The AI nailed it, identifying potential gold spots near unique geological formations. And get this, it did this over a vast area, which really narrows down the search. So instead of just bigging everywhere, they could focus their efforts. Seems like that could save a ton of time and money. You got it. And it's better for the environment because there's less drilling and digging overall. A win for the miners and the planet. This reminds me of all the work you do to teach people about geology, especially on your YouTube channel. Over 550 videos. It's a great resource for anyone interested in geology, wouldn't you say? You're right, I love sharing what I know about geology. My YouTube channel lets me reach so many people. For anyone listening who wants to learn more, you can find it at https://bud.youtube.com/vals geoconsultant-videos. It's packed with info on all kinds of geology stuff. But back to our deep dive. We talk about AI finding gold near the surface. But what about the deposits that are buried deep underground? Any way to find those too? Definitely. And AI is a big part of that as well. Take a study about finding deep fee polymetallic deposits in China. These are deposits full of iron and other valuable metals, and they usually form near major tectonic plate collision zones, like the one they studied. Those collision zones are like geological pressure cookers. Right. Creating all that heat and pressure to form those valuable deposits. But finding them deep down must be tough. It is, but they came up with a smart approach, combining AI with traditional geology knowledge. They call it a data knowledge dual-driven model. So how does that work? What data did they feed into this AI? They started with a mountain of data, geological maps, rock samples, magnetic readings, all that good stuff. Then they use graph convolutional neural networks, or GCNs, to make sense of it all. GCNs. Yeah. What are those and why are they so good for this kind of analysis? GCNs are rock stars at finding patterns and connections in complicated data sets. It's like giving the AI the power to see how different geological features are related and how those relationships might point to where the gap is. So the AI learns the language of geology, figuring out how unique features interact and what that tells us about what's hidden underground. You got it. But they didn't just let the AI go wild. They used their own geology expertise to guide it. They built in geologically constrained layers, which basically told the AI to pay extra attention to specific features that we know are important for this type of deposit. So they're like AI whisperers, using their knowledge to focus the AI on the most promising areas. Blending human expertise and AI seems powerful. It is, and the results were seriously impressive. The AI model found several high potential areas, and a lot of them matched up with known deposits, which proves it is accurate. More importantly, it highlighted areas that we might have missed with the old ways of doing things, opening up whole new possibilities for exploration. It really shows how this approach can help us find hidden resources and better understand the Earth's mineral wealth. It's like we're entering this whole new age of exploration with AI, leading the way to discoveries we couldn't even dream of before. But finding these deposits is just the start. To actually mine them responsibly and efficiently, we need to really understand their structure and how they formed. You're exactly right. Take the King Changyu deposit, for example. It's known for copper, gold, and molybdenum, and researchers use these high-resolution ground magnetic surveys to map it. It's kind of like using a giant metal detector to create a 3D image underground, highlighting areas with different magnetic properties. So like giving geologists X-ray vision to see through the ground and visualize the deposit structure. What did they learn from that? It revealed this intricate network of faults and fractures, which often acts as pathways for fluids that are full of minerals. These faults and fractures can act like, well, conduits, concentrating those valuable minerals into zones within the deposit. So by mapping those faults and fractures, geologists can get a better idea of where the best ore is, leading to more targeted and efficient mining. Exactly. But there's a catch with these magnetic surveys. Rocks can hold on to magnetism from the Earth's field over time, which we call magnetic remnants. This can mess with the signals and make it hard to get a clear picture, like trying to listen to a radio station with a bunch of static. Gotta filter out the noise to hear the music. Perfect analogy. And that's what the researchers did. They came up with some really smart ways to clean the data and get rid of the interference from those magnetic remnants. The result, a much clearer picture of what's underground. So they cleaned up the data and got a more accurate view of the deposit. What did that reveal about King Changyu? The improved images showed a network of previously unknown rock bodies, several kilometers deep. These suggest there's a much bigger potential for deeper deposits than we thought, which could extend the mine's life significantly. That's a big deal, not just for the mining company, but for the whole local economy and the people who depend on those jobs. This discovery shows how important it is to use these advanced techniques to understand these complex geological systems. It also reminds me of how important it is to share this knowledge like you do on your YouTube channel, which has over 550 videos on different geology topics. I appreciate you saying that. Making geoscience accessible to everyone is something I'm really passionate about. I think it helps people understand our planet better and appreciate the challenges we face. For anyone listening who wants to learn more, head over to provide URL from source material. You'll find much great info presented really engagingly. But let's get back to our deep dive. We've talked about AI finding gold near the surface, but how about how these deposits actually form in the first place? Let's stick with gold since it's such a fascinating and sought-after metal. How does gold go from being scattered in the Earth's crust to those rich veins and lodes? The journey of gold from deep inside the Earth to those concentrated deposits is a fascinating story full of geological processes and chemical reactions that take millions of years. It all starts with magma, that molten rock beneath the Earth's crust. So magma is like the birthplace of gold. What happens next? How does gold get out of the magma and start its journey toward those valuable deposits? Well, gold isn't evenly distributed in the magma. It likes to hang out in certain areas, often associated with specific types of magma that are richer in dissolved metals. But the gold doesn't just stay there. It needs a way to travel upwards, closer to the surface where we can find it. That's where magmatic fluids come in. We've talked about these fluids before, right? Mineral-rich elevators carrying those valuable metals through the Earth's crust. That's it. These fluids, often loaded with dissolved sulfur, are key to transporting gold from the magma to shallower levels in the crust. Sulfur seems to be a big deal on this golden journey. Why is sulfur so important for gold transport? Sulfur and gold have a special bond. They form chemical complexes that let gold dissolve and travel in those hot pressurized fluids. Think of sulfur as gold's travel buddy, helping it navigate through the Earth's rocky maze. So sulfur is like a golden passport, letting gold move freely through the Earth's crust. I like that. But these fluids can't travel forever. Eventually, the gold needs to be deposited to form those concentrated deposits miners are after. To understand how that happens, let's look at the Oberon gold deposit in Australia. It's a perfect example of how geological forces and fluid flow work together to create those rich gold veins. Okay, let's head down under. What makes the Oberon deposit so special for understanding gold formation? The Oberon deposit shows us how important shear zones are in gold deposition. These are zones of intense pressure and deformation in the Earth's crust, usually found near tectonic plate boundaries. Picture those massive tectonic plates grinding against each other, creating zones of intense pressure and breaking the rocks. So those shear zones are like the Earth's pressure points, where rocks are being squeezed and deformed. Exactly. These shear zones create pathways for those gold-carrying fluids to flow through. As the fluids travel, They interact with the surrounding rocks. And that's where things get really interesting. What kind of interesting are we talking about? What makes the gold come out of those fluids and form those concentrated deposits? It's this delicate balance of factors, changes in pressure, temperature, and the chemical makeup of the surrounding rocks. Remember, those fluids are hot and under pressure, and they're carrying dissolved gold, right? Like those golden elevators we talked about. Exactly. As those fluids flow through the shear zones, they run into different rock types with different chemical compositions. Sometimes those rocks contain minerals that really love gold. So it's like those minerals set a trap for the gold. You got it. When the fluids encounter these mineral traps, the gold is pulled out of solution and deposited, slowly building up those rich concentrations over time. It's amazing how those processes, deep inside the earth, create the conditions for those valuable gold deposits to form. But finding those deposits and understanding how they formed is only part of the story. To mine them responsibly, we need to know what's down there before we even start digging. Absolutely. Predicting what's beneath the surface is key for efficient and responsible mining, and AI is having a big impact in this area too. Let's look at how deep learning is being used to create a decision support system for drilling, especially in the oil and gas industry. We talked about decision support systems before, but can we dig a little deeper? How are they being used in oil and gas? Imagine a system that can go through tons of geological data and then predict the most likely spots for oil and gas reservoirs, helping companies decide where to drill. That's what these AI-powered decision support systems are doing. It's like having a virtual geologist analyzing data and making recommendations based on years of experience and knowledge. I like that way of putting it. These systems often use two powerful AI techniques, generative adversarial networks, or GANs, and forward deep neural networks, or FDNNs. We've heard those terms before. Could you remind us what GANs and FDNNs are and how they team up in this context? Think of GANs as the creative brains of the operation. They learn from huge data sets of geological formations and then generate realistic models that capture the complexities simpler models miss. They're like the Michelangelos of the geological world, creating detailed virtual representations of what's underground so they can generate those intricate 3D maps of the underground, showing different rock layers, faults, and where the oil and gas might be. Exactly. While the GANs are busy creating those visualizations, the FDNNs are like the speed demons of geological simulations. They take those complex models and run simulations to predict how different drilling scenarios might turn out, so they can test different drilling strategies virtually, helping to figure out the best placement and how to get the most resources. That's it. And they do it incredibly quickly, giving real-time feedback as the drilling is happening. This is super important for geosteering, which means adjusting the well path as you go to target those oil and gas rich formations better, like a GPS for drilling. But instead of roads, it's navigating through complex geological layers with the help of AI. Sounds like this could make drilling a lot less risky and expensive. Absolutely. By reducing uncertainty and improving drilling accuracy, these AI systems are making oil and gas exploration more efficient and less harmful to the environment. It's another great example of how AI is changing geoscience, making it smarter, more efficient, and more sustainable. But we've covered a lot today, from ancient tectonic plates to AI finding minerals and guiding drilling. You know what? It's got me thinking about the incredible work being done by folks like you to make these complex topics understandable and accessible to everyone. Your YouTube channel, with over 550 videos on all sorts of geology stuff. It is a fantastic resource. I appreciate you saying that. Sharing my passion for geology with a wider audience is something I'm truly dedicated to. For anyone listening who wants to learn more, they can find your channel at https www.youtube.com vols geoconsultant videos. It's a treasure trove of information, and I encourage everyone to check it out. And with that, we've come to the end of another deep dive into the fascinating world of geology. It's been a pleasure exploring these incredible discoveries with you. The Earth is this incredibly complex and dynamic system, still full of mysteries, just waiting to be unlocked. So, to everyone listening, keep exploring, keep learning, and keep those questions coming. Thanks for joining us on Geo News Radio.
My name is Ricardo Valls. I am a professional geologist registered in the province of Ontario, Canada, and also the president of Valls Geoconsultant. Geology, geochemistry, structural analysis, machine learning, and artificial intelligence. I am sure you will find something useful among my over 550 videos.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.